Hi and a very good day to everyone. Today I'm going to present about determining circuit model parameters of three-phase induction motor from the subject of electrical machines, code number BEJ 20403, presenting by group 6. Now, I would like to introduce myself and my team members. I'm Navina Shubhashchandra with the metric number CE240237. Iqlin Najah binti Talib with the metric number CE230008. Third, Muhammad Idlan bin Anwar, CE230152.
Okay, thank you, Navi. Okay, let's continue with our presentation. My name is Iqlin Najah binti Talib, CE230008, member of Group C, Section 1. Okay, today I will explain about the test 1 and test 2. For the test 1, I will explain about the DC test of the three-phase induction motor, MATLAB simulation. For the purpose of the test, the DC test is performed on a three-phase induction motor to accurately determine the stator winding resistance, which is a key parameter for motor analysis and modeling. Next, the simulation setup. In this MATLAB simulation, a direct current DC voltage of 5 volt is applied across two terminals of the stator winding and the resulting current is measured. So we use the value of C because we are from group C. For the setup a synchronous SI unit, we draw the circuit in the simulated MATLAB, which have a synchronous machine SI unit, voltage measurement and display. Since we are from group C, we need to set the square cage mode to 6, which have 150 horsepower, 60 Hz and 1785 RPM. Then we run the simulation to get the value current to find the R1. We wait until the timer is stopped. So the measured current in this test is 83.96 ampere. Since the current passes through two stator winding in series, the stator resistance per phase is calculated using the formula R1, which is equal to VDC over 2IDC. Okay, for the test 2, I will explain about the block rotor test of the three-phase induction motor. Firstly, we need to draw the circuit correctly in MATLAB Simulink. Okay, this is our circuit. Purpose of the test, the no-load test is performed to determine the core loss magnetizing current and parameters related to the shunt branch magnetizing reactance and core loss resistance of the induction motor equivalent circuit. We need to change the value of voltage 1 volt until 5 volt to see the value of I phase, V phase and PST. For the simulation setup, in this MATLAB simulation, the three-phase induction motor is run at its rated voltage and frequency, but without any mechanical load connected to the shaft. The input line voltage, line current, and power drawn by the motor are measured under this no-load condition. This test helps in determining the parameters necessary for the equivalent circuit of the inductive motor, specifically the magnetizing reactance and core loss resistance. These values are essential for accurate motor modeling and efficiency calculation in MATLAB simulation. Okay, we see the voltage change until 5 volt. We take the reading of I phase, V phase and PSC and we do the calculation. After that, we continue to the next test. That's all from me. Thank you. Okay, for the test 2, I will explain about the block rotor test of the 3-phase induction motor. Firstly, we need to draw the circuit correctly in MATLAB Simulink. Okay, this is our...
Now, I would like to explain about calculation of block rotor test of 3-phase induction motor. So, line current ISN is equals to 1210 VA, while the power factor is equals to 0.2564 with a power angle of 75.14 degree. So, impedance per phase impedance, which is equals to 0.1818 ohm, and expressed in a rectangular form, so it will change into 0.1757 ohm. So stator copper loss, which is equals to 2.7044 watt, and rotor copper loss is equals to 1.5266 watt. So for the right hand side, line current is equals to 110 VA, while power factor is 0.2563, impedance is 0.1757 ohm, which is XLR, RLR 0. Okay, I'll continue with the impedance per phase. ZLR is equal to 0.5011, which is 0.1818 ohm. So convert to rectangular form, which is 0.0466 plus J 0.1757 ohm. So that again we have to convert to RLR, which is 0.466 ohm. XLR is 0.1757. So the stator copper loss is equal to 10.8174 watt. And the rotor copper loss is equals to 6.1026 watt. Okay, well, the third part of this calculation is input power, which is equals to IL 16.5 ampere, VL is 220 watt. So the apparent power is 1210 VA. The power factor is equals to 0.2564. When you convert to angle, it will change to 75.14. So the impedance is equals to 0.1757, which is XLR. RLR is 0.0466 ohm. So the stator copper loss is PCU, which is 24.3392 watt, and rotor copper loss is equals to 13.7408 watt. So okay, while for the middle part, input power IL is equals to 22A, S is equals to 1210 VA. So the power factor and angle, which is equals to, power factor is 0.2564 and the angle is 75.14. Impedance Z is equals to 0.1818 with a cos 75.14 angle plus with J sin 75.14 equals to 0.466 plus J 0.1757. So the stator loss is equals to 43.696 watt and the rotor loss is equals to 24.1044 watt. Okay, while on the right part, input power is equals to 24.4467A, which is IL. S is equals to 10778548 VA, power factor, and angle is equals to 73.27, which is an angle. Impedance is equals to RLR 0.05888 ohm, XLR is equals to 0.1955 ohm. So the stator loss is equals to 53.6479 watt. So the rotor loss is equals to 52151 watt.
So this is our test 3 project, which is no load test of the 3-phase induction motor. So as we can see, this is our circuit. So by using the library browsing, we need to find the component to complete this circuit. Okay, so I create based on the reference suitable. So first of all, we need to include the value of the max, which is 220 square root 2. And then for the frequency, we select the 50 hertz. And also the asynchronous machine as a unit, we need to select. And then for the rotor type, we need to choose the squirrel cage for this project. And then the squirrel cage preset model, we need to use or select the number 6, which is the value of from the table that given each group. So after that, we need to apply. Okay. After that, we can run the simulation. Okay. So as we can see, the electromagnetic display, the output is 3.383, and then the rotor speed, which is the RPM display, 1500. So the value of B phase, which is we have 3. For the first is 221, second 209.9, and lastly 228.7. For the island equal I phase, we got 62.18, 65.03, and lastly 59.7. And lastly PSC, the value is 883.5. So that's it, and then we go through the test 4.
Now moving on to test 3, calculation of no load of 3-phase induction motor. So for the first step is you have to calculate the value of total resistance ZEQ, then calculate XM by using the X1. So with the answer ZEQ you will get 3.49660. From the block rotor test, X1 is obtained 0.0899. So XM is equal to 3.4067. So for the third, calculate the value of stator copper losses PSC1 with the formula of 3I square times R1 with the final answer of 351.01 watt. So for the last final step, calculate the rotational losses of the motor. So PROT equals to PSC minus PSC1, which is equals to 532.49 watt.
Hi, so this is our test 4 project, which is simulating top speed characteristic of 3-phase induction motor. So we can see the circuit that I create using the reference suitable, and we also can find the component from the library browser and search the component that we need to use, like a circuit that I create. So this circuit is also same as test 3, but we only add on the ramp speed, scope, and the XY graph component. For the asynchronous machine as a unit, we set the rotor type as a squirrel cage, and for the value uh, of the preset model, we use number 6, which is 150 horsepower by referring to the value in table uh, to each group. So the frequency, we set at 50 Hz for this test project, and then we can start running this circuit simulation. So we can see the value of RPM, V9, I9, and also P input. So we go through the XY graph to see the output graph. So this is our output from the circuit, and then we can select the data cursor to plot the higher signal. So that's all from our group. Thank you.